Welcome to the Year 4 lesson for Whole Unknown. In this lesson I'm learning to use repeated addition to solve whole unknown questions. Let's imagine I come across 3/4 of a cake, and on that 3/4 of a cake there are 6 candles evenly spread around it. I want to work out how many candles must have been on the whole cake. Well, here you can see I've recorded what that question looks like. So the denominator tells me that there are 4 pieces of cake. So I can draw that down here, and the easiest way to do that is to draw a rectangle and split it into 4 pieces. Now the numerator tells me I'm interested in 3 pieces, so I can draw a circle around those 3 pieces. Remember, these 3 pieces are the only pieces that I can see. This quarter over here is missing. Presumably someone's eaten it. Now in our part unknown questions, we had a number here, and that number was the total amount of candles on the cake, but that's what we're trying to find out in this question. Instead, we're given this number, and that's the amount of candles that are on just this little bit of cake, just the 3 pieces. So these 6 candles must be shared among 3 pieces. And you can see my 3 pieces down here. Well, I know if I have to share 6 candles among 3 pieces, I'll have to put 2 candles on each piece. So now that I've done that, it's obvious to see how many candles must be on this piece at the end. It must also have 2 candles on it. So now I can work out how many candles must be on the whole cake. 2, 4, 6, 8. So in this gap up here I can write 8. 3/4 of 8 equals 6. Let's try another question. This time I've come across 2/5 of a cake, and there are 6 candles spread around those 2/5 of a cake. So I can record that like this. The denominator tells me that the cake has 5 pieces. So I draw out a rectangle and split that rectangle into 5 pieces. The numerator tells me that I am interested in 2 pieces. These are the 2 pieces that I can see. So I'm going to come and circle those 2 pieces. And remember, this number here is the number of candles that are on the 2 pieces that I can see, not the whole cake. That's what we're trying to work out. So I need to share these 6 candles between the 2 pieces. Well, I know that must mean I need to put 3 candles on each piece. So now you can see if there's 3 candles on each of these pieces, there must be 3 candles on these pieces. So now it's easy for me to add all of these up and work out how many candles must have been on the whole cake. 3, 6, 9, 12, 15. So 2/5 of 15 equals 6. Let's try one last question. This time I can see 2/3 of a cake, and there are 10 candles shared around those pieces. So I'm trying to work out how many candles must have been on the whole cake. Well, you can see I've recorded that like this, and my denominator tells me there are 3 pieces. So I'll come over here and draw my rectangle and split that into 3 pieces. My numerator tells me I'm interested in 2 pieces. Those are the 2 pieces of cake that I can see. And remember, this number at the end tells me how many candles are on those 2 pieces. So if those 10 candles are shared between 2 pieces, there must be 5 candles on each piece. So if there's 5 candles on those pieces, that means there must be 5 candles on this piece as well. So now I can work out how many candles must be on the whole cake. Well, 5 plus another 5 is 10, plus another 5 is 15. So there must have been 15 candles on the whole cake, or 2/3 of 15 equals 10. Let's have a think about the important things to remember in this lesson. Well, we're still using a diagram to help us answer this question. This number, the denominator, tells us how many pieces there are. The numerator tells us how many pieces we are interested in, or how many pieces we can see. And this number here tells us how many candles are spread around this number of pieces. And what we're trying to do is work out how many candles there must be on the whole cake. You can find the activity sheet that goes with this lesson in the Teacher Tools Fractions, Decimals and Percentages book from the Whitebook collection.